Hi everyone, welcome to another video, and today we're going to discuss about a new question called random pick with weight. So in this question, it suggests that we will be given an array of positive numbers, may or may not be in sorted order. So we can pick a number out of this array in a random way, and the probability of getting that particular number is that number divided by the sum of all other number in that array. So let me explain this on the whiteboard. So let's consider an example um, that is that's an array consisting of 3, then 14, then 1 and 7. So as per the question, if we pick a number randomly of this from this array that contains only 4 numbers, for example, we pick a number from maybe 1. So the probability that we will get 1 will be 1 divided by the sum of all the number, that is 25. So it will be 1 by 25. Similarly, if we pick 3, the probability will be 3 divided by 25. For 14, it will be 14 divided by 25. For 7, it will be 7 divided by 25. That's the requirement. So then, consider a box, right? Consider a box that has a number 3 and there is no other item. So what will be the probability of getting 3 out of this box? That will be 1 by 1, right? Because one coin and only one total number of coin is 1. So 1 by 1. So now if we add another coin, maybe 1. So the total becomes 2. So what would be the probability now of getting 3? That will be 1 divided by 2. Similarly, the probability of getting 1 will become 1 by 2 as well, right? So what if there are 3 coins total, and now what is the probability of getting 3? That will become probability of getting 3 here is 2 divided by 3. Consider that now we have, for this example, we have 25 coins. So how we can get 3 by 25? So we should have 3 coins that represents 3. Similarly, how we can get 14 by 25 probability from this box? We need 14 coins representing 14, right? And similarly for 1 and for 7, we need 7 coins for 7 and only 1 coin for 1. And if we put those numbers, that number of coins here, then we pick 1, then the probability of getting 14 will become 14 by 25, probability of getting 3 become 3 by 25, and so on. So you got the gist here. So we need a box of 25 numbers, right? So that numbers will become like 0 to 25, right? Now then, from here, if we create buckets, either we can repeat the number or we can create buckets. Okay. And now to realize that situation where we create, if we need 3 by 25, we created uh, 3 coins in that box. Similarly, when you created an array of 25, to get 3 by 25 uh, probability, we will need three numbers that represents 3. So 0, 1, 2. Okay. Or from 3, sorry. We'll go up to 3. Start from 1. Okay. So it become 3 coins. Now to getting 14, so we're gonna add 14 to 3. So that will become 17. So from 4 to 17, this bucket represents 14. Similarly, we're gonna, after 17, we just have 1, so 18. This bucket represents that 1. And after that, from 19 to 25, that bucket will represent 7. Right? Now then, if we select a number from 1 to 25, okay, then we find it in what bucket it is there. For example, we pick a number called 8. And if you find out where this number lies, so we're going to find this bucket, second bucket. So that represents 14 then, right? And 14, then we have to return the index 1. Okay, so how are we going to find it? Now, because we have the random number that is generated and we have bucket here, and the bucket represents the cumulative sum, that is like 3, 17, then 18 and 25. Only this 4 number we need to consider, right? Let's see an example here, right? For example, our cumulative sum will become now 3, 17, 18 and 25. And if we pick a number randomly from 1 to 25, let's pick 8. Okay, then now we're going to start our left pointer at 3 and right pointer at 25, or last index, and then we're going to calculate our mid, will be here. And then, is mid greater than 8? Yes. So then we'll be moving our right cursor to the mid, and the new mid will become now 1 and 0. So 1, 0, so 0. New mid will become 0. So is 0, is 8 greater than 0? Yes. In that case, we have to move our left index to right. That will go here. Now our loop will break here, and we have to return this index 1. So now then, let's implement the solution using JavaScript. So first thing first, step 1, right? Create a cumulative sum array from the given array. So let sum equals to 0, and for each w, for each, let sum plus equals to element, and then let's create, let's cs equals to array, and then we're gonna push our sum to that array. So cs dot push. So this will create our CS array, or cumulative sum array. Now in step 2, we need to get our random number. Random. So let random is equal to math dot random by our sum. Okay, the last index. So this will give us the random number. Step 3. Step 3. We need to run our binary search. We search on CS to find the index, right? So to do that, let's initiate our left and right pointers. Pointers equals to 0 and our w dot length. Which one? Last index. And we're gonna run our while loop. While left less than right. First thing we're gonna compare if our target, that is rand, is greater than the current index. First of all, we have to find the mid, right? Let mid equals to uh, med.floor. Then you're gonna create like left plus right divided by 2. And then if our cs.mid is smaller, is greater, make it greater than rand, then if cs mid is our target and then our left, right, if our target is greater than mid, then we'll move our left. So let's do that. If rand is kind of greater than mid, cs.mid, then our mid will become mid equals to left plus 1, right? Then else we have to move our right pointer to the mid. Else right equals to mid. And right, so it's plus 1, then mid will come back, and yeah, it should work. Now let's try that the solution in our Leet code. We're gonna copy the function content. Now let's go to Leet code. Now paste it in our peak method, and we have to then access w. So this dot w equals to w, so that we can access that here. So this dot w, is there any w somewhere else? Yeah, here. This dot w, any other w? No. Now let's run it. Time limit exceeded. What error happened? If rand greater than cs mid, target is greater, then we have to move mid. Jesus. Left equal to mid plus 1. What we are Doing left equals to mid plus 1. This should solve. Perfect, it's passing, and now let's submit it. Wow. Why? Let's submit again. Horrible efficiency. I don't know why. But I already submitted this solution before and the efficiency was better. Same solution. Let me see what's happening here. You see that submission here? See, the same solution and it was, the efficiency was too high here. Much better. Beats 87%. And after some time, okay, I get what I'm, what. Okay, let's do it. Let's do it. So only thing I find difference is like we did not have any content in our solution here, and all the stuffs we have written in the peak index tab, but we know this is the solution. But let's see if that's what causing the efficiency thingy going bonkers. Let's see. So let's create it. This stuff. Yes. Okay. Fine. Now wherever this is, we're gonna insert this. Yes. Okay. The some of the codes we transferred to our main class, and we don't have access to some now. This type some. Okay. Uh, Perfect. It passed. Let's submit again. Same solution and efficient one, only because we transfer the code between the main method to the class declaration, and suddenly the efficiency is high. Leet Code, what to do. Anyway, that is the solution. Thanks for watching. See you in our next video.